Quadratic sequences occur when the difference from term to term changes. In this chapter, we will look at higher-level questions, such as finding a formula for the nth term and deducing expressions to calculate the nth term of a quadratic sequence.
The way to recognise if we have a quadratic sequence is finding the second difference. Let's look at this sequence: 2, 6, 12, 20. The first difference from term to term changes each time. It is +4, then +6, then +8. But notice the second difference is +2 each time. When the second difference is constant, you will have a quadratic sequence. An n-squared term is involved. It's important to know the rules when looking at differences of quadratic sequences, and these must be learnt.
If the second difference is 2, you start your nth term with n squared. If the second difference is 4, you start your nth term with 2n squared. If the second difference is 6, you start your nth term with 3n squared.
So let's deduce the nth term of the following sequence: 3, 9, 19, 33. Take the first difference to start with, and then the second difference. If that difference is constant, we know we have a quadratic sequence.
We do have a constant second difference, and the +4 means our nth term will start with 2n squared. The only thing left to figure out is what else we do in our expression to get the numbers in the sequence. Let's take n equals 1. We want an answer of 3. We already know part of our nth term is 2n squared, so let's do that bit first. 2 times by 1 squared equals 2 times by 1, which equals 2. To get from this answer to 3, we add 1. Our nth term will now read 2n squared plus 1. Let's check with term 3. We should get an answer of 19. 2 times 3 squared plus 1 equals 2 times 9 plus 1, which in turn equals 18 plus 1, which is 19. As we get the right answer, we can confirm the nth term is 2n squared plus 1.
Now let's try another sequence. We're given 2, 9, 18, 29, 42, and we're asked to find the nth term. We can see the first difference is +7, then +9, then +11, and so on. This means the second difference is +2 each time. Because it's constant, we have an n-squared sequence. Now we need to look at the difference of the n-squared term and the numbers in our sequence. We can see our first differences are +1, +5, +9, +13, and finally +17. Hopefully you can see the second difference here is +4 from term to term. This makes the sequence 4n. To get back to the number in the sequence, we minus 3. So the second part of this quadratic sequence is 4n minus 3. We then put the whole quadratic together using the fact it was an n-squared sequence at the start, and we get n squared plus 4n minus 3. This is the nth term for our sequence.